A byproduct of the mitochondria doing its work as the engine of the cell is oxidative stress. Too much oxidative stress leads to less optimal health. Inflammation, cancer, dementia, diabetes, learning disabilities.
In the evening, melatonin is released from the pineal gland. And we've all heard that melatonin can help us sleep. People take melatonin as a sleep supplement. I know it's important for that, but you're saying it also goes into the mitochondria of our cells and combats oxidative stress?
That's exactly correct.
Okay, so that process works at night. How do mitochondria in our cells deal with oxidative stress during the day?
Well, that's a very good question, because any type of light that hits the human eye is going to shut down the production of melatonin from the pineal gland. And so there has to be a completely different system that is put in place during the day that allows melatonin to be made in the mitochondria to deal with the oxidative stress. Infrared radiation from the sun, which we'll talk about, actually goes into the mitochondria and is producing melatonin on site. This is what the science is now starting to discover, making it very interesting as to how much sunlight are we getting and what happens when we don't get enough sunlight. As we look here at the solar spectrum, you'll see that 39%, just 39% of the energy coming from the sun is in the form of visible light. And we can see that here between 400 nanometers and 760 nanometers wavelength. You can see everything to the right of red is known as infrared because it has a wavelength longer than red. And that is divided up into near infrared and far infrared. At the other end, all of the light, as you can see, that is beyond the purple or violet in this case, ultraviolet, is not seen, but we know that it's important. Specifically, UVB is important in making vitamin D. But I want you to notice something very important. 54% of all the energy coming from the sun is in the infrared spectrum. One of the things that's really important is understanding what lux is. And so we've got an example here where we have a candle, which is 1 lumen, 1 meter away from a board, which is 1 meter by 1 meter, and that's described as 1 lux. And in this slide here, you can see that 1 lux is kind of like twilight at night, and that a family living room is about 50 lux, but it can go all the way up to 1,000 if you had an overcast day outside. And if it was a bright and sunny day, that would be around 100,000 or even more lux. And so that kind of gives you an idea when we talk about exposing your eyes to light at a certain lux level. This is a good reference point for understanding light and its intensity. The human body is extremely complex. And because of that, there are so many processes that are occurring that it's not just one continuous thing. There are times of the day where certain things tend to happen and times of the day when other things don't. So I wanted to show you here what I'm referring to, and just to give you an example of what we talked about with oxidative stress, we can see here that melatonin secretion starts at 2100. That's about 9 o'clock at night. We call that dim light melatonin onset, because if you are watching dim light, then it's going to basically start to secrete melatonin from the pineal gland. But if you notice, as we go around this cycle, melatonin will stop at approximately 7:30 in the morning. Dim light melatonin onset is kind of a bad name for it because really it's the absence of light that allows the pineal gland to stimulate and produce and secrete melatonin throughout the blood and the human body. You're right that it may not be 9 o'clock in everybody, and that's the problem, is this circadian rhythm has to fit onto reality. This is a clock that's going on inside your body. But the problem can come in is if your clock is not in tune with what reality is on the outside. In other words, there's a certain part of your body, your circadian rhythm, that's attuned to when you should be awake. And if it's not correlating with when the sun is up, you might have some problems. So yes, the circadian rhythm, which is very finely regulated inside the body, but the question is it actually in line with what's happening outside the body, what reality is? There's been a number of studies that have been done both in rodents and in humans that when they apply the dysregulation of the circadian rhythm in rodents, we can see problems with body temperature, increased fat, altered immune system, tumor developments, and basically just perturbations of the hormonal homeostasis. In human beings, when they do this prospectively, they show that there are problems with insulin regulation, leptin, and norepinephrine, and also increased markers of inflammation and diabetes.